Yep, it's a short unit, unit 4 is only 6 lessons long. And lesson 6, just like lesson 5. That's how important it is. We want to put it all together one more time. So they're going to be a little bigger than yesterday. And we have a polynomial here. And we have our brains trained to immediately think the following. Whenever we're given some polynomial, the first thing we should always do is get ourselves a picture whenever possible. That means whipping out Desmos, whipping out your calculator, and getting a picture. All right, in this picture, we shouldn't be that shocked about it. We see that it's a cubed and that it's positive, so it has one tail down and one tail up, with the leading tail going down because of the positive in front of the cubed. Next thing, you should always determine how many possible roots. Well, that's easy. Since it's to the third power, we know there are 3 roots possible. But we know now that some of these roots could be real and some of these roots could be imaginary. So when we look at our picture over here, it crosses the x-axis once. So that means we have 1 real root and 2 imaginary roots. Now, could a cubic function ever not have a 0? No. One root of a cubic function always has to be real, and that's because of the tails. In fact, any odd function always has to have at least one real root, because the tails, one up, one down, at some point will cross the x-axis because they go on for infinity. All right, so how about looking at these roots? Can we find what these roots are? Well, one of them is given to us. That's easy to do. That is the root 1. So if we know there's a root of 1, that must come from a factor of x minus 1. Now we have to find the other factor that multiplies together and get x cubed plus 3x squared plus x minus 5. And once again, we did a little bit of this yesterday, but these are a little harder now. So I'm going to go back to dividing. I'm going to take x minus 1 and divide it into x cubed plus 3x squared plus x minus 5. And this time I'm going to use the table method. So remember, we would put the x cubed here, and we would say, okay, what times what got me x cubed? Well, if this is x, this is going to have to be x squared, which makes this minus x squared. Okay, let's continue our table here. Next thing I'm trying to find is x squared, and that has to be 3x squared. So this must be 4x squared. Remember, along this diagonal right here, they have to add together to get me 3x squared. So that would be 4x. That would be minus 4x. Still need one more table. And once again, this along here is going to have to add to a plus x. So that is going to make that 5x. So that's going to be 5. Let's get this line out of here. And voila, minus 5 is what we get. So I guess the other factor turned out to be x squared plus 4x plus 5. All right, so now we know that that's the other factor. We know it has to be imaginary. So once again, I'm going to solve it. But this is how quickly we expect you to solve a simple quadratic. I'm going to complete the square because my leading coefficient is 1 of my x squared. And I should be able to lickety-split run through completing the square. The 5 goes over to the other side, getting me a negative 5. So I have x squared plus 4x. Take half of 4, which is 2. So that means the binomial has to be x plus 2 squared. 2 squared is 4, which means I must have added on 4 to both sides to get this. So that's negative 1. Now to solve for x, I take the square root and move this 2 to the other side. So x equals negative 2 plus or minus the square root of negative 1. So x equals negative 2 plus or minus I. Yes, in fact, I could have done that quicker, and I expect you to do it quicker. Honestly, this is as quick as I would do it. X squared plus 4x equals negative 5 is as far as my brain goes. Then I jump right to the answer. I know that half of 4 is 2. And if it's positive 2 when it comes to the other side is negative 2. Squared means plus 4, so that means it's negative 1. The square root of negative 1 is I. That's how fast we want you to do completing the square. May look like razzle dazzle, but you have to learn that. So there we are. There are my 3 roots. 1, negative 2 plus I, and negative 2 minus I. Here's another one. Let's analyze it. Boom, it's a cubic. So that means there are 3 possible roots. Let's get a picture of it. We know that since it's positive, one tail down and the second tail is up. Yep, there it is. Okay, we know it has a real root of 1. Not the answer is 1. There is one real root. That's what I should really say. So that means there are 2 imaginary roots. All right, so if I wanted to find those 2 imaginary roots, I'm going to have to do a little division. So here's my table over here. I like to work backwards. They told me my root is 3, so that must come from the factor x minus 3. Okay, so I'm going to have to use this factor of x minus 3 and divide it into my x cubed minus 3x squared to find my other factor that I can then factor to find my imaginary numbers. All right, so if this is x cubed, this had to be x squared minus 3x squared. Well, I want a minus 3x squared, so that's going to make life real easy. Whoops. Come on, there we go. So that's going to be 0x squared. So that must be 0x. We love this. That was easy to do. And then, wow. There we go. And then our last one, we want it to be 4x. So this has to be 4x, which means this has to be 4, which this is minus 12. All right, so what did our other factor end up being? An x squared plus 4. So now I can set that equal to 0. X squared equals negative 4. Solve it. X equals plus or minus 2i. There are my 3 roots, 1 being real, 2 of them being imaginary. All right, example 3 here. X cubed plus 5x squared. By now, we know it's cubed. One tail down, second tail up because it's positive. We have our picture in front of us. And right now we have 3 roots and 2 of them seem to be real, which means 1 is imaginary. Okay, so my roots are negative 5, which means it came from the factor x plus 5. And then we have 0, which means it came from the factor of x. If I multiply that together, I get x squared plus 5x. Well, I need x cubed plus 5x squared. Well, hopefully you can see that if I just multiply that by x, I get my x cubed plus 5x squared I'm looking for. So 0 was really a double root. So guess what? In this equation right here, there were no imaginaries. We had to analyze it further to see that there were 3 real roots and no imaginary roots. And for this last one, we're going to just, again, look at it very quickly. See how the roots are crossing in ugly spots? Well, thank you. We're not going to solve this one. Again, it's how many zeros does p have? Well, since it's to the 5th power, they must have 5 zeros. How many real roots? Well, looking at this, it has 3 real roots. And since there are 3 real roots, 2 of them could possibly be imaginary.